Dimensional analysis is a method we use to rename a measurement to use a different unit of measurement. For example, we could say that 1 week and 7 days mean the same length of time, but using different units of measurement. This is useful in everyday life, especially in cooking and shopping. I might have a recipe that calls for 4 cups of cream, but the store only sells cream by the pint. How many pints does my recipe require? Dimensional analysis rests on the identity property of multiplication, which says that any quantity multiplied by 1 is equal to the original quantity, even if the product looks different from the original quantity. We want to buy the same amount of cream that the recipe calls for, so we want to say that a certain number of pints is equal to a certain number of cups. We'll multiply the requirement in cups by 1 or something equal to 1 to get the right number of pints. It's this something equal to 1 that gives dimensional analysis its name. If we take the identity property of multiplication and divide both sides by our original amount, we get an interesting fraction. It tells us that any number divided by itself is equal to 1. What's not immediately obvious is that the numerator and denominator don't have to be identical. They can be equal even if they look different. Let's look at an example. We know that 1 year is equal to 12 months. We can divide both sides by 1 year and get a fraction that's equal to 1. Or we can divide both sides by 12 months and get another fraction that's also equal to 1. We can do this starting with any statement that 2 measurements are equal. Here are some more examples. From 1 foot equals 12 inches, we can get 1 foot over 12 inches is equal to 1, and we also get 12 inches over 1 foot is equal to 1. From 1 pint equals 2 cups, we get 1 pint over 2 cups equals 1, and 2 cups over 1 pint is equal to 1. So here's the method that we'll use to figure out how much cream to buy. We'll write an equation, and on the left side of the equation, we'll put the units of measurement we want to know, and on the right side of the equation, we'll put the units of measurement we already know. In this case, we want to know how many pints, and we already know how many cups. We know that we need 4 cups of cream for the recipe. I'll write that as a fraction by putting it over 1, for reasons that'll be clear in just a minute. Then let's multiply the right side by a fraction that's equal to 1. We've seen lots of fractions that are equal to 1, but we want one that talks about cups and pints. And we found 2 of those, but which one should we choose? I'll tell you how to choose in just a minute, but for now, I'll pick the better one and show you the method, and later on I'll show you what happens when we choose poorly. I'm going to choose the fraction that shows 1 pint over 2 cups, which we've already convinced ourselves is equal to 1. Now we have 2 fractions multiplied on the right. That's why I put cups over 1 in our first equation. Now we can use all of your skills in multiplying fractions. Let's multiply straight across the numerator and multiply straight across the denominator. Don't forget to multiply your units of measurement. That's critical to using dimensional analysis. In our product, we have 4 times 1 times cups times pints on top, and on the bottom we have 1 times 2 times cups. Now, we can divide out any units that show up on top and bottom. Here we have cups on top and cups on the bottom, so we can cross these off pairwise. 4 divided by 2 is 2, so what we need is 2 pints. So we need to buy 2 pints of cream. We have pints on the right and pints on the left, so we have reached our destination. We've found the thing we were looking for. We wanted to know pints. Now, let's see what happens if we choose our conversion factor poorly. It starts out the same way, but this time I'm going to use the other fraction, the one that has cups on top and pints on the bottom, just to show you how wrong it can go. Let's multiply straight across the top, multiply straight across the bottom, and on the top we have 4 times 2 times cups, and on the bottom we have 1 times 1 times pints, which gives us, let's multiply, 8 square cups divided by a pint, which is nothing like the pints that we were hoping for on the left-hand side of our equation. And I have no idea what a square cup would look like. So by choosing 2 cups over 1 pint, that was a bad choice. Could we have predicted that this was going to happen? Yes, we could have. Here we had cups in the numerator, but we wanted the cups to go away. We don't see any cups in our want to know. We wanted the cups in the numerator to go away, and we accomplished this by choosing a conversion factor that has cups in the denominator, so that the cups on top would divide out the cups on the bottom. This is part of our strategy. If you have a unit of measurement on top that you want to go away, choose a conversion factor that has that unit on the bottom. If there's a unit on the bottom that you want to get rid of, choose a conversion factor that has that unit on top, so they'll divide out. Let's do another one. This one's going to have two conversion factors. Let's rename 5 feet to centimeters. Here we have centimeters on the left. That's what we want to know. And we have 5 feet on the right. That's what we already know. As we look at our equivalence chart, there's nothing there that talks about how many centimeters there are in a foot. But we do have feet to inches and inches to centimeters. So we can multiply by 1 twice. We can two-hop this problem. We have that 1 foot equals 12 inches. So we could use 1 foot over 12 inches, or we could use 12 inches over 1 foot. Which one to choose? Well, we have feet on top in our already know, so let's use a conversion factor that has feet on the bottom, so feet will divide out. Now we have inches on top, but we want centimeters. Our conversion chart says that 1 inch is pretty close to 2.54 centimeters. So we can use 1 inch over 2.54 centimeters, or we can use 2.54 centimeters over 1 inch. We choose the one that'll help us get rid of those inches on top. So let's choose the one that has inches on the bottom. Then we can multiply all the way across the numerators. We can multiply all the way across the denominators. Feet divide out, inches divide out, and we're left with just centimeters. So there are about 152.4 centimeters in 5 feet. This is basic dimensional analysis. We can make it a little more complicated. We can use the same tool for calculations using rates, but I'll save that for another video.